and welcome to this video tutorial on converting decimal base 10 to binary base 2 and vice versa. First of all, I'm going to start by converting a decimal number here, 42, to a binary number. Now I've got a table here to help us do that, but first I'm just going to explain why I've written this subscript 10 here. Now, often in questions you'll find that a number, they won't tell you what the base is, but they'll give you a number in subscript here. And that just denotes the base. So, for example, over here I could have the number 10. That could be binary 2, or it could be decimal 10. So, to let you know which one of those it is, they're just going to put a subscript number here, so that's the base of the number. Okay, so the reason I've written these powers of 2 here is because you can find the decimal value that you're going to need in this column, or this row rather, here, by doing 2 to the power of whichever bit you're on, starting from the least significant bit. So here we've got 2 to the 0, that's obviously 1 because anything to the power of 0 is 1. And here we've got 2 to the 1, and that's 2 because anything to the power of 1 is just itself. And 2 squared is 4, and so on until we get to 2 to the 7, which gives us 128, and that's our 8 bits. So how are we going to convert 42 to a binary number then? Well, using this table I can work my way from the most significant bit to the least significant bit and see whether or not 128 will go into 42, and it won't. So here I'm just going to put a 0 because 128 is way bigger than 42, as is 64 here. But then we come to 32, and as 32 is less than 42, and we haven't got any numbers with a 1 yet, so we can start off by putting a 1 in the 32 column, and that just gives us a binary representation of 32 to start off with. So we're building up to 42. 16, well, if we take 32 away from 42, we're not going to have 16 is going to be too big, so we're going to put a 0 in there. But then we come to 8, and if we take 32 away from 42, we're still going to have more than 8 left, so we're going to put a 1 in there. And then we come to 4. Well, if we take 32 away from 42 and then take 8 away from the result, we're going to have less than 4, so we're going to put a 0 in there. If we're going to look at 2 here, if we take 32 away from 42 and then take 8 away from 42, we're going to be left with 2, so we can put a 1 in there. And since now, if we take 32, 8 and 2 away from 42, we're going to be left with 0, there's obviously not going to be a 1 in there, so that's going to be 0. So we've got our 8-bit representation of 42. So the answer here is 0, 0, 1, 0, 1, 0, 1, 0. And we'll put a little subscript 2 there to show that is a binary number. Okay, now I'm going to do it the other way round. So our second problem is converting this binary bit pattern to decimal. Now, what we're going to do is we're going to... This is actually much easier to start off with, because all you need to do is put your bit pattern into the table here. So we've got 0, 1, 1, 0, 0, 0, 1, 0. Then you're going to look at what numbers you've got in the columns with 1s, and in this case we've got 64 plus 32 plus 2. And if you add that up, you'll get 98 in base 10, and that's your answer. Okay, and that's just a brief introduction into converting between base 10 and base 2. Thank you for watching.